I was right.
So, Tommy, I want you to fill in the blanks again. Try it again.
Okay, poly.
Means?
Many.
Many. Good.
Nomial.
Answers?
Number.
We're going to say terms.
Terms.
That's pretty
Same
close.
difference.
Monomial has 1, 2, 3. So, how many of you, and this is just a kind of a poll because we're trying to figure out if this was taught in Algebra 1, how many of you know what the word degree means? Degree.
Like what kind of degree?
Yeah.
Like multiple.
Like out of the little.
Like a college degree, like a
No, like in math, if I were talking about a degree of
Angle?
The highest like power?
Maybe like
the highest power, good. So, the degree of a term means the exponent of the variable. So like what exponent is attached to that term. So if I were to go and label the degree of each term, so I have 1, 2, 3, 4, 5, I have 6 terms total in this polynomial. If I were to label the degree next to each one, what would the first one be? The degree would be 5, then what? 4, 3, 2, 1. What about this next one? 0. Good. If it doesn't have an x attached to it, it's like saying x to the 0 power. It has no degree. The degree of the polynomial, so each term has a degree. As a whole, the degree of the polynomial is just your highest degree. Good. So in this case, it would be 5. And then the last vocab would be the leading coefficient. What do I mean when I say coefficient?
The number in front of the exponent.
Yeah, the number before the x or something. So the leading coefficient is going to be the number in front of the highest degree term. So our highest degree is 5. What is the leading coefficient of that? Good. So here's what I want you to do next, and you can work on this with a partner or by yourself. You are going to go to the chart, and we're going to actually discover or fill in what we think the end behavior is, and so then we'll come back and talk about it.
What do you mean by end?
So I want you to go to your chart, and I want everybody to put in the first polynomial. So I think that it is 2x squared minus 2x minus 11. Before we even graph it in our calculator, we can already fill in the degree and the leading coefficient. So what's my degree? 2. And my leading coefficient is also 2. I want you to go ahead and graph it. And it says use the following windows. So the x is from -5 to 5. The y is from -20 to 20. Okay, so if I were to graph it, what does it look like? A parabola, like this. When I'm talking about end behavior, it's what your graph is doing to the left and to the right at the end. So in this case, they're both facing what? They're both up. So in the end behavior, I'm going to draw just 2 up arrows and put both up. Number of turns just means how many times it changes directions. So just 1 time, going down to up. And how many zeros does it have? 2.
That is not at all what my graph looked like.
So both up, so end behavior that we just put both up.
Mm-hmm.
You're doing the next one?
Yep, so what I want you to do is do the next 3. and fill them in. I'm going to give you about 5 minutes, and then we're going to talk about some patterns that we see. So, first page, what do you notice, first of all, about all of the degrees? They are all what?
Even.
Even.
Why?
2, 4, 2,
It
6.
goes in the same way, I think.
So, also, what do you notice about the end behaviors?
They're
Also,
both in
they're
the
all
same
the
direction.
same.
They're going in the same direction.
so if they're even, then they're in the same direction.
Yes.
They're odd.
What's another thing? So, some of them are up and some of them are down. What do you think that's connected to?
The negative.
The leading coefficient.
Yes, so we've got a positive leading coefficient, positive, positive, negative, negative. So that means that it either points up or points down.
Wow. Look at that
What's
chart.
another connection that you see or something?
The number of turns.
The number of turns is always one less than your highest degree.
Wait. This is the back or
This is the front.
Is the number of zeros, is that the number of signs in the equation that isn't the first negative?
Do what?
So for the first equation, it has 2 negatives, and then there's 2 zeros, and then the second one, it has 4 signs, and there's 4 zeros.
No, I don't think. So number of zeros, they all match with our highest degree, except the last one. And what do you notice about the last one?
It
The
doesn't
fourth
have, like,
one.
The leading, it doesn't have the continuous, like, going, like, it's 6, then 4, then 2. It doesn't go like 2, then 1, then nothing.
Yeah, it doesn't go like 6, 5, 4, 3, 2, 1, nothing, right? And all of these have a nothing on the end, and they kind of go down. So I'm not going to make you graph this, but if we added plus 2 at the end, that would make it shift up 2. And then you would end up having 4 zeros. If we put plus 3.5 at the end, that would make it shift up 3.5. And then you would have 6. So the number of zeros won't always match the highest degree visually. And we'll talk about maybe there are some zeros that you can't see later on in the chapter. Let's go to the next page. So now all of my degrees are what? They're all odd. What do you notice about end behavior connected to the odd ones? They always go opposite directions. And some are going up and to the right. Some are going down and to the right. How do I know that?
Is it by the first negative? If the first, if the leading coefficient is positive or negative, does that affect?
Yes.
So if it's positive, then the first end behavior is down, and then if it's negative, it's up.
Yes. So what I would do if I were thinking about it, instead of thinking about the first one, think about the last one, like what it's doing to the right. So whatever it's doing to the right is going to match the sign of your leading coefficient. It's going up and to the right on a positive, down and to the right on a negative. Now, how can I remember this? How am I going to remember that even go in the same direction and odd go in different directions? What are some parent functions that we already know that match this or follow this kind of
X
thing?
squared and X cubed.
X squared. So an X squared looks like this, right?
Yep.
What does a negative X squared look like?
Down.
Down.
Wow.
What are parent functions with odd degrees?
Wow. I like that.
The X cubed.
The X cubed
Duh.
looks like this.
Wow.
That's an awful picture. What does a negative X cubed look like?
Draw that.
What's another odd one that's a parent function that you may not think about?
What's it called? Well, I mean,
Square root of X. 1 over X.
No, not the 1 over X. No.
Is it the absolute one?
It's like the easiest one that you're not thinking about.
Just the regular
X,
one.
just regular X.
Oh my gosh.
Because it's X to the first power, right? So that's odd. And it looks like a line. Are they going in opposite directions?
Yes.
Yes. And what's it doing to the right?
Going
Up. What's negative x?
Wait, what? I missed something.
Oh my.
Going down.
My whole life is different. Well, we just finished the whole lesson.
So that's how you're going to be able to remember end behavior, is by thinking about x squared and then either x cubed or a line. Odd, even, okay? And then positive versus negative. Because just straight memorizing it sometimes doesn't work. So just refer back to the ones you already know. Okay, let's turn to the next page of notes.
I'm so lost. Wait, I didn't get the key. I didn't write it down.
I will post it back up in a minute. So let's fill in what we know. It says, if you have an even degree, then what happens with the end behavior?
Both sides same.
Both ends same direction. Good.
One direction.
Positive means that they both go which way? Negative means they both go.
Down like our grades.
That was weird. I'm going to draw my pictures. Odd degree means they go in opposite directions. If it's positive, what is it doing to the right?
Down to up.
It's increasing. So, looks like that. Down to up. If it's a negative, then it's decreasing.
Up to down.
The next thing we discovered is that the degree of the polynomial determines the maximum number of turns and the maximum number of zeros or x-intercepts or roots. I could call them any of those things. So the maximum number of turns we discovered is what? Degree minus 1. Whoops. Degree minus 1. And the maximum number of zeros is what? The degree. Can't get more than that. So you couldn't have an x squared with 3 zeros. So let's look at
Nope. Yep.
perfect. So the first one, not a polynomial, because why?
It breaks.
There's a break and there's a hole. Those are bad. Second one is no.
There's multiple points.
Yeah. It kind of stops at a point. It's not continuous. Second one is yes. So let's talk about what kind of function it could be. Would it be even or odd?
Even.
Good. Would it be positive or negative?
Positive.
How many turns does it have?
1, 2, 3.
1, 2, 3.
Yeah, let's do.
So, and how many zeros?
2.
So the degree we're going to say is greater than or equal to 4. Because the maximum number of turns is degree minus 1. Okay, the next one is yes. I want you to fill in the things that I did on the third one. So, is it even or odd, positive or negative, how many turns, how many zeros, and the degree. Okay, odd or even? Positive or negative? How many turns?
4.
How many zeros?
2.
3. 1, 2, 3.
Oh. Uno, dos, tres.
And the degree is greater than or equal to what?
Cinco.
5. Good. Y'all are awesome. This isn't that bad, right?
Oh, it's gone.
I'm just waiting for it to get worse.
It's
Yeah,
not.
exactly.
It's not
No,
going to get
This is
worse.
so easy.
Yes, it
This
is.
so easy.
Legit the next page.
And then
What
there's
does
gonna be
deg
some
mean?
Okay.
problems with letters.
Degree.
Deg sounds like a-
So I'm not going to you're not going to use your calculator, but also your graph doesn't need to be perfect. It's just what you think it could look like. Okay? So we're going to start from the beginning and just fill out what we have. Then from there, we'll sketch a graph. Degree, highest degree is what? 4. My leading coefficient.
-1.
So maximum number of zeros could be what?
3.
4. Because it's equal to the degree. That's
Equal to the degree?
for zeros. For turns, it's subtracting 1. So that would be 3. So the first thing I do when I sketch my possible graph is the end behavior. So the degree, is it odd or even? And then my leading coefficient, is it positive or negative? Negative. So that means that they are going to be doing what? Both going down. So I'm going to put 2 arrows like this. So if they're both going down, I want something that has 4 zeros and 3 turns. So try to fill in the middle. Doesn't matter where they hit or what they do, but it needs to have 4 zeros and 3 turns. So mine's going to kind of look like an M.
Ooh. Manche.
Hey, you do the same thing.
Nice. Okay, I want you to try number 2. Okay, here's what I got.
It's wrong.
It's wrong.
It's wrong.
Odd, positive, max zeros are 3, max turns are 2.
Why are there fractions?
Okay, let's look at the next
Oh,
one. Fractions don't matter.
They don't
They
matter.
do.
They don't. They don't because we're not doing anything with the fraction.
Yeah, the
So
fraction
my
is
leading
legit.
coefficient and my degree are hidden in the middle. So it's not always the first term. It's just the highest one. So in this case, it's not written first, but it is which one?
3.
So my degree is 3. And my leading coefficient is what?
3/4 negative.
Negative 3/4. So I'm going to write a little note that the highest degree is not always written first, and it could be in the middle hidden, and it could be there to trick you. Because I would never try to trick you, right? Never.
You want to look at the
But
test?
but I'm warning you that it may not always be first, so you need to check.
It's probably gonna be like.
So the maximum number of zeros could be what?
3.
And the maximum number of turns could be? So for end behavior, degree is odd or even?
Odd.
Positive or negative? Negative. It's negative 3/4. Okay. So it's going to be up, then down. And it's going to kind of look like the second one. Like that. Okay, try number 4.
Are you kidding?
Okay, here it is.
Confusing.
Just gotta think about it.
Count how many times
Or was it
up
my
and down.
Wait.
Yeah.
1, 2, 3, 4, 5.
I think you have one too many. Or maybe two too many.
So many. It's okay.
Okay, let's look at the last question. So here we have 2 graphs that are given to us.
Okay.
So what's true? So I just want to want to face the facts here, just looking at it. What are some things that we can deduce from part A?
It has
The degree is
odd
odd
number.
and the positive is a positive.
Degree is odd,
Leading coefficient.
Positive.
and we have a positive
Leading coefficient.
leading coefficient.
1, 2. Can be greater than.
Degree.
The degree could be greater than or equal to 3, because it has 2 terms. Let's just leave it at odd positive right now.
Yeah.
Okay, what about the second one?
Negative. Even.
Even, negative.
That's it.
Perfect.
Class dismissed.